Hi everyone, my name is Josh Stella and I am the CEO and co-founder of Fugue. And it's great to be here presenting at DevOpsDays Boston. Uh, I'm going to be talking today about serverless security and IAM. These are closely related topics because of the nature of serverless security. And we'll walk through some real details. If you're deeply technical, I think you might learn some things in this talk about how some best practices and some vulnerabilities that you're probably unaware of. If you're not deeply technical, I think this talk is also for you. You're not going to struggle to understand anything I'm talking about. I'm going to lay it out in pretty clear and concise ways. I've got a small number of slides. I'm going to spend a few more than I normally do. I think I've got 8. I'm going to spend time at a whiteboard, okay, diagramming this stuff out, and probably a little time at a web browser too. Okay, let's jump in. So the agenda today, I'm going to be setting the table first on serverless security and IAM. Just explaining what we're talking about here and, giving you a high level sort of overview. Then we're going to go into some deep dives. I'm going to diagram out a serverless architecture and talk about how you can deploy and build these things in a secure way. I'm going to make a long list of recommendations on how to do serverless security in the cloud. And then, of course, we'll have time for Q&A. A little of my background. Prior to founding Fugue, I was at AWS as a principal solutions architect, primarily focused on national security customers, Department of Defense and similar. Fugue, I'm a software architect and programmer for most of my career. And Fugue itself is built largely using AWS Lambda. And we have dozens of customers, including a lot of Global 2000s, banks, big international banks. Early on in Fugue's history, In-Q-Tel were investors. That's the investment arm of the intelligence community. And our customers trust us to secure their critical cloud assets, and we secure millions of them. And we do that with a serverless application. Fugue itself is mostly built in Lambda. So that's why you should bother listening to me, I suppose. Okay. So why we need to rethink security in a serverless world. Oh, I've got some text going under my speech bubble there, but many of misconfiguration vulnerabilities, especially in serverless, but this is true of cloud in general, involve IAM. IAM is really the principal network in the cloud, in cloud native applications, and I'll show you this as I'm diagramming, and this is what the hackers are often focused on. So a lot of these dangerous configurations or misconfigurations, when you look at compliance standards, the various CIS ones, NIST, HIPAA, GDPR, et cetera, and we cover dozens of these in Fugue. A lot of the things that are dangerous in serverless are not considered by those very effectively or very deeply. And I think it's because many of them are really evolutions of pre-cloud ways of thinking, data center ways of thinking, which are largely irrelevant to things like serverless. So your compliance standards, which whether or not you're beholden to, SOC 2, for example, we are SOC 2 accredited. Whether or not you're beholden to these, very often they're used by the security team in order to give them a kind of basis for understanding what's dangerous and what isn't. And a lot of these cloud misconfigurations on serverless and IAM are just not seen as problems by those. And that means they're often not seen as problems by the security teams because they're reliant upon them. A lot of them also are only apparent or are even only detectable in the full context of an environment. So Fugue, for example, we do a lot of great infrastructure as code checking for, Terraform and CloudFormation and so on. And you can catch a lot of things there, but there are a lot of things also that you have to see the entire cloud environment post-deployment and relate the things to each other in your policy as code to understand our actual vulnerabilities. This ends up meaning that most of these things, many of these things, are overlooked in security audits. One of my favorite G2 reviews of our product, and it's a positive review, but it begins with, Fugue is going to hurt your feelings. We're going to find stuff, right, that you've overlooked, and any good security vendor should. This all means these add up to these kinds of dangerous misconfigurations are exceptionally common in cloud environments, and hackers are exploiting them regularly. And very often when hackers exploit a cloud environment, you don't notice. In some of the big breaches we read about in the news and have read about, the only way that the breached party knew was when they get extorted, or when the hackers, in one case, bragged on social media. Okay, let's talk about the shared responsibility model. This is conceptually simple, but in practice is something you really need to study and understand how your architectural decisions in cloud are going to impact this for you. The good news is, if you're doing serverless, it's more on the cloud provider and less on you, and that's what you want. So this is the AWS representation of the shared responsibility model. It essentially is saying anything orange is on AWS and anything blue is on you, the customer. Now, let's talk about the orange part. So we're talking here about regions, availability zones, edge locations. We're talking there a lot about physical security, who can walk on a data floor, things like that. And then the hardware that's running within those that makes up the cloud service provider's global infrastructure, whether you're using AWS or Azure or GCP or probably others. Those are the ones I'm mostly familiar with. They're gonna cover that stuff. You don't need to worry about the actual hardware. They will also cover, in the orange bit, compute, storage, database, and networking, if you're using the managed versions of those services. So at one extreme, for example, would be you're going to build applications using virtual machines, and you're going to maintain the operating systems, and you're going to patch the libraries there, and you're going to load your application source code into it, etc. In that scenario, the cloud service provider is responsible for securing the outer boundary of the virtual machine, but everything inside it is on you. When you go to containers, that shifts it a little more into the orange. It's a little more managed, right? You're no longer maintaining the underlying operating system beneath the containers. You're just managing the containers. But there's a lot in a container. When you go all the way over to serverless, almost everything is pushed into the orange, and that's desirable. What you want is for the cloud service provider to have more responsibilities, because that's undifferentiated heavy lifting that you're not having to pay for. Undifferentiated heavy lifting meaning if you are a bank, who cares how good at patching operating systems you are? It's not going to add to your top line or your bottom line. If you're a tech SaaS, many of our customers are big tech companies running SaaS. Their business is not maintaining compute infrastructure. Their business is, having a valuable, either B2B or B2C application out there. So, in our opinion, pushing more stuff into the orange is wise when you can do it. You can see a lot of things in blue here. For example, operating system, network and firewall configuration. Well, certainly operating systems, if you're doing serverless, are no longer your concern. You can't see them. When Fugue was going through our SOC 2 audit, our auditors asked us our patching processes and documentation, and we said we don't have any because we literally don't manage any operating systems in our application, in our SaaS. We've pushed all that onto the CSP. And the CSP is better at this than you are. I really don't, it doesn't matter to me who you are. I've worked in a lot of national security environments. I've worked for AWS, and I can tell you they are probably the best at this stuff in the world, the cloud service providers. Other things like how you've configured encryption and how you are doing, you see up here in the blue, identity and access management, right? That's part of what we're going to be focused on, because even if you push a lot of the, database responsibilities and compute responsibilities, operating responsibilities onto the provider, you still have to be very concerned with what can talk to what and what can it do when it talks to it. Okay. Let's talk through this. Okay, it says deep dive here. We've only got a 30-minute session. So what I'm going to do is spend this time at the whiteboard, because that's probably the quickest way to really talk through this. Okay, let's hope my whiteboard is working properly. Oh, that looks pretty good. Okay, here we go. So let's talk about a serverless architecture. Well, actually, first let's talk about a traditional virtual machine, and this kind of applies to containers too, kind of architecture in the cloud, and then we'll go to serverless. Okay, so in a very traditional 3-tier architecture, you would have compute instances, EC2 instances, and those could also be containers, although that works a little differently. And you might have, for example, a web-facing tier. You typically have an application tier. Oh, I'm mixing where I'm putting things. I'll put them beneath. So the circles are virtual machines. And then you probably have a database if you're doing any kind of like real-world application. And very often the security boundaries between these things are defined by a couple of things. One is the kind of login credentials from the web server to the app server, or the app server to the database server, but also the network routes that are allowable. So in your traditional 3-tier application, and you probably have, some boxes up front, maybe, application firewall, or, firewalls you're going to have, intrusion detection systems, and so on. But you've got these kind of like network boundaries around these different functions of the app, and typically these things are going to be secured based on some combination of ACLs, CIDR blocks, TCP/IP network kinds of things. So the typical pattern here would be that the web servers can initiate conversations to the application servers, and these are typically clusters. These are not an individual box. In the database might be one large instance, but typically these are clusters. And then the app server can initiate conversation to the database, but you use TCP/IP restrictions to prevent, for example, the web servers from talking to the database. That's not allowed. Or perhaps the application servers talking to the internet. That's not allowed. And you definitely don't want, the internet going either way to the database. That's not allowed. So in your traditional model, you're really thinking about things typically in terms of network and application security. Identity is an inferred part of this. And what I mean by that is your app servers, the fact that they're in the subnets for the app servers is a kind of identity, right? That's where the app servers go. Ergo, if something is in there, it's an app server. With serverless applications, this just has, in most cases, literally nothing to do with how you defend serverless applications. In serverless applications, you're really using identity as the network. And this is also true for a lot of kind of virtual machine-based environments in the cloud and so on, if you do them right. But this idea of having network perimeters and a network defense in depth and intrusion detection systems sitting between tiers, that is the wrong way to think about this. You can try it. It will not work very well, and it will cause a lot of really bad, from a security perspective, really bad architectural compromises. All right, let me just erase all this, and let's draw a serverless app. Okay, so in a serverless app, we know we're not managing a full instance or an operating system or any of that. We're managing, in AWS's case, things like Lambdas. Now, some people say serverless and they're talking about containers. I don't think that's a valid thing to do, personally. Containers are kind of like a hybrid between a virtual machine and a true function as a service, truly serverless architecture. That's what we're talking about here. Now, at Fugue, we do run some containers, but those are not seen as serverless parts of the system. They're seen as containers. All right, we're talking about true function-based serverless. So what you're going to end up doing, and typically when you're going serverless, you're kind of forced, if you do it well, to decompose your application from. There's really no opportunity to run a monolith in a true serverless architecture. So by definition, you're kind of going to a microservice architecture. Well, what does that mean? It means instead of having the app servers, you've got a whole bunch of Lambda functions or cloud functions, and Google or whatever, but probably dozens or hundreds of these things, and they are chained together on a per transaction basis to achieve some result. All right, you're going to have a lot of these, and they talk to each other, and they talk to other things. So what are some of the other things they talk to? Well, obviously, in most cases, if you're running a public service, you need to talk to the internet. So we'll put the internet over here, just give it a big I. Now, what you don't want is internet traffic directly going to the serverless components. That there's risk in that. So you want some layers here. We believe that the API gateway service is a great way to interface between your customers, the users of the system, and the guts of the system, the business logic of the system. There's all kinds of stuff you can do in API gateway, not just routing requests to the right kind of entry point in the serverless architecture, but also establishing trust and authentication and authorization and carrying those tokens through. And you'll see that ends up in our recommendations. So you're also going to end up with some kind of persistence, right? So we might have an S3 bucket, or we might have an RDS database. Okay, so we end up with, there's the kind of front edge, over here, where we're taking traffic in from the internet, and then depending on who is asking, the identity of the customer, that gateway is going to start doing things like calling some entry point lambda, and it's probably going to be calling other lambdas, and there will be some chain of these through the system, and then eventually some of them will need to talk to storage of one form or another. And then the response, right? So we've gotten the request. The response, quite possibly, let's do this in blue, comes back a sort of different route. Okay? And that might go straight out to here. All right, what I'm showing you here looks a lot like a network diagram, a really sloppily drawn one, but it is a form of network diagram. Now, the ability for each of these components to talk to the components it needs to are defined by their IAM policy, by their identity and access management policy. We're not talking about users, human users. We're talking about, for example, this Lambda having permission to talk to this Lambda, having authorization to do that. And the way it does that is by having its own identity. All right, and that identity is mapped to a policy. Now, what you don't want is a policy that says this Lambda alpha here, this Lambda A, can talk to any Lambda. That's a bad idea, right? You don't want that pattern. What you want is for it to just be able to talk to the things it actually needs to talk to. And that is true all the way through the stack. Particularly when you're talking about the databases and the data persistence tiers and the internet. Okay, these are over here. I'll use a multicolored pen. These are the like really dangerous boundaries, if you will. But again, they're not network boundaries, not TCP/IP network boundaries. They're identity network boundaries. So that's the problem space. This is a short. Oh, and my alarm is going off there. Let me stop that. This is a short form of this presentation, so I'm going to have to move along pretty quickly here. What do we have? Just 5 minutes left. So I'm going to go to recommendations. But I hope you understand the problem space. We have some long form classes on these topics on our YouTube channel. Hours and hours of this stuff. So if this is intriguing to you, I would suggest going there. Okay, let's go back to some slides and talk about recommendations. So, when you are defining those policies that say which Lambda can talk to which Lambda and which component can talk to which component, you want the least privilege possible, right? Not talk to all Lambdas, just talk to this one. And what we think that means in practice is that you're going to create an IAM role with a policy for each function. And that means it should be part of your application development. The generation of those things should be automated. Otherwise, it will get overwhelming, okay? Be really careful with cross-account IAM. Cross-account IAM can blow all kinds of holes now and in the future that you may not be aware of when they happen in the future. So be very careful with that. That should be scrutinized. All right. Of course, you should do code reviews, right? When you're writing Lambda functions or serverless functions, you still have to write secure code. Delete things you're not using. This says delete Lambdas delete everything you're not using. Hackers love orphaned infrastructure. They are really good at exploiting it. So don't leave it around. Minimize dependencies, keep them up to date. Here we're talking about good hygiene in the open source libraries you're using, etc. There's There's lots of tools out there to help you with that, Sonatype and Sneak and others. This next one's interesting. This surprised us, but I'm really glad we discovered this because it's important. An individual Lambda instance, right? So when a Lambda gets called, it gets born, it gets instantiated into existence, an instance of that function, and then it processes whatever transaction caused it to wake up, if you will, to instantiate. Well, that same exact instance can then be used, and this is a desirable behavior from a performance perspective, for other transactions. Now, those other transactions in this kind of zero trust methodology we're talking about here, where the tokens for authentication and authorization come all the way through along with the transaction, that next transaction is quite possibly for a different user. So if you are using the execution environment of the Lambda to store any kind of sensitive data, you have potentially exposed yourself to cross-tenant data leaks. And that's a bad thing. So don't do that. Treat Lambdas like real Lambdas in programming, and limit side effects, and try real hard to be very disciplined about where you do persistence. Yeah, it's a bad idea to do shell scripts in Lambdas. Anything that is aware of the kind of underlying operating system is a bad idea. For a number of reasons I don't have time to get into because I only have 3 minutes left. Okay. Yeah, you should put these things behind an API gateway and use the authentication mechanisms in the API gateway. Definitely. And also, it's a good idea to use a WAF in these situations. So you're not completely absolved from, you don't just write Lambdas. You still have to think about security architecturally outside of just Lambdas. As it says in the top key takeaway, serverless security is deeply architectural. It's in fact completely dependent upon the architecture. But you still need to secure tactically things like the source code, okay? New serverless code can still contain old, well-known vulnerabilities. You can, if you are pulling in wrong versions of libraries that have, CVEs in them or something, you can be inheriting those CVEs. IAM is your primary vuln surface, but not the only one. This is an interesting one too. VPCs are usually thought of, if you have an option to put something in a VPC, as safer. In the case of Lambdas, it's generally a bad idea from a security perspective because it actually opens an additional attack surface with the IP address space. Boy, I'm just about out of time. So define your core secure configurations and reuse those and modify them when you're generating those templates. Definitely use a tool to check this stuff out. You can use ours. There's a free form of ours. We will help you understand if what you're doing is secure. There are others as well. EC2 resources. When you're putting either EC2 or containers into serverless environments, you are opening additional attack surface, and depending on how those identities are managed, how broad the access to the serverless environment from the servers, depending on how broad that is, this can blow wide open your blast radius for what an attacker can get access to. Again, 1 IAM role per function. I'm going to fall within the 30th minute, I believe, here. So this is recorded, but I'm here in the future from the recording time. I'm here live, and I'd love to get some questions. That's the fun part. Questions, challenges, whatever. I'm Josh at fugue.co. Thanks so much for your time.
All right, let's kick you up some Q&A with Josh. Let's kick off some questions here. So, where are some resources where folks can learn a little bit more about this?
Yeah, that's a good one. So this was a pretty short presentation. We actually record a lot of classes on this and many other cloud security topics on our YouTube channel. So if you know, and it's all free, you don't have to register or anything. So the Fugue YouTube channel, we have a series of master classes, including a 2 hour session on serverless security. So
Awesome. Love it. All right, so how about some more bad? Let's or some more ugly stuff. Anything in particular that you've seen that is some kind of awful in the serverless and IAM space?
I mean, the most common thing that you see, and of course, you know, I do a lot of reviewing of what people are talking about in developer forums and so on the internet, and so I'll see these kind of very naive understandings. The most common error is setting lambdas to be able to talk to any other lambda, especially to be able to execute, which is really what that means in most situations. And people do that in dev, and the problem is if you're doing that in dev and you say, well, we'll tighten it down later, you're not going to. And this is particularly true in serverless, because to do serverless least permissive patterns properly, in our experience, means part of your dev cycle should be when you're introducing a serverless function, that you are automatically generating its least permissive IAM policy as part of the dev process. So that is a slippery slope that if you go down, oh, we'll manually tighten this up later, you're never going to get there once once the horse is out of the stable, so to speak. Um,
Yeah,
yeah, the other thing is people tend to think that, you know, there are two things we touch on there briefly, but just to expand on them in the presentation briefly, to expand on them a little. Um, you know, time. When you're thinking about attack surface, most people think about like breadth. You know, what APIs are exposed. Time is sort of the z-axis of attack surface. So when and this is, serverless goes a long way to flattening that, to reducing that. But there are two things to really think about. Time is your enemy. In other words, the longer lived something is, as a hacker, the easier my job becomes, and the more people like me will notice it. So if you have an EC2 instance or a container that's long running, that should be viewed as something that is completely untrustworthy in the serverless environment. You should only be interacting across those boundaries with the less secure assets, and I would argue that definitely containers and virtual machines are less secure than serverless functions. You should be treating those things as exploited, and that means having really good, you know, zero trust relationships between those things.
love it.
I think those are the main things.
Love it. Yeah. All right. Let's go into some something slightly different. Infrastructure as code or infrastructure as software. How has that changed the game? Is that just adding more complexity, or is that actually potentially stopping things earlier? I mean, what's your opinion on that?
Well, we actually have a big product launch today on Fugue IAC. We actually invented policy as code for infrastructure back in the mid-teens. It's a really good thing. So IAC solutions that are out there and got popular are, you know, Terraform, CloudFormation, etc. Security really wasn't part of the design, and there are some kind of attempts to paste stuff on, but you really have to have security as a fundamental part of that. And so the way that we think the right way to do that is with policy as code, and that policy as code should be applicable. The same policy as code, we use Open Policy Agent for this, should be applicable both to the IAC template and to the running infrastructure, so that you have one way to deal with that. It works beautifully with serverless because a bunch of stuff you can catch in at the IAC stage. So, for example, we do a lot with our product. Of course, we run our product on ourselves. We are checking for overly liberal IAM policies in the infrastructure definitions and the templates, and then we're monitoring them once they're deployed using the same policy there. So I think solving for security at the IAC layer is really important, but it is not a complete solution. Cloud infrastructure is mutable, and so you have to keep it running in the production environment as well.
Yeah, I agree 100%. I think some folks have, you know, implemented something a little bit more myopic where they have just the prevention and infrastructure code, and that doesn't get out the gate. But then they maybe neglect auto remediation for things that exist. And I know everybody owns some infrastructure that they didn't build themselves. And I think having that scanning or ability to look into what's out there today is super critical and important. Glad you brought
And to
that up.
tie those together, right? I mean,
Yeah.
you should be able to see them tied together. You can't even deploy everything using IAC in clouds. So you're going to have stuff that's not in, Terraform or CloudFormation.
Love that. Very true. Very true. Okay, so let's talk about the combination of serverless architecture and some of those things that are living in our environments that are perhaps not serverless, EC2 workloads or any cloud workloads or VMs, and maybe some K8s workloads or any kind of orchestration container workloads. And in how do they when they interface? Is there any known good patterns for that, or anything that it's like a gotcha that you want to look out for?
Sure. So the way the term microservice architecture is everywhere. It's really what we're really talking about is service-oriented architectures. Microservice suggests a collection of really small ones for largely for scalability and decomposition. My advice as a software architect, no matter and by the way, most things should not be microservices unless you need them to scale, because debugging across distributed systems is harder than you think if you haven't done a whole lot of it. Your tooling, I mean, there's really good tooling out there, but it's just a thorny, nasty problem, especially when you get in like item potency of interfaces and where your transaction boundaries are. You really have to know what you're doing. And I see a lot of people doing microservices because they're trendy. So the way I think of it is all service interfaces are 100% defined, not by their implementation, but by their API, syntax and semantics. So whether or not from a connection perspective from other services, so you really shouldn't care too much if you're deploying using Kubernetes or a virtual machine or a managed database or a Lambda function. Um, when between those things, they should be untrusted toward each other, except on an individual transaction basis, and limited to the APIs as they're exposed. Put another way, if you're architecting this correctly, in my view, what I think is good architecture, it should not matter if it's a VM or a container or a Lambda behind that API, as long as the API acts the same way. And that's going to inform you on your security as well. The big one I see people make a mistake on is, and I mentioned this in the presentation, but is thinking that putting Lambdas in a VPC helps security. It does not. It hurts security. You should have no TCP/IP identity of any of these functions, and that removes an entire attack surface. You definitely should not configure security boundaries based on TCP/IP networks between things like VMs and serverless functions. That it should always be on identity.
Love it. All right, we've got one more question. Um, let's talk a little bit about policy as code. How do you think that is helped environments today?
I think it's just starting to. We actually at Fugue we wrote a full formal functional compiled language for policy and infrastructure back in the teens when we were mostly doing national security stuff. Um, and so it had this very fulsome ability to express policy as code. I'm thrilled now. We are thrilled now to see Open Policy Agent really gaining popularity. Most of the other things that we're trying to do policy as code were half measures at best. OPA is Rego is the language. It's a real language based on data log, and you can have developer tooling around it. And we've actually written a thing called Frego you can get off of our GitHub. So we're excited about policy as code now because it looks like OPA is gaining in popularity and traction, and it actually can solve the problems there. So we use it extensively at Fugue. All of our IAC policy stuff and all of our runtime policy stuff is OPA based. I think it's starting to have an impact, but what we tend to see is people are just waking up to the fact that policy as code is the correct answer, and that it is actually a pretty profound answer. That it can solve a lot of these problems in a lot of places in the stack. So I think the future of policy as code is super bright. I wish people had gotten wise to that a few years ago, but I love that they're getting wise to it now.
I couldn't agree more. Great stuff. That's it for the time that we have today. If folks do want to continue this conversation, we can talk about security, serverless, policy as code, and maybe some future solutions there. I'd love to talk with some more folks in the breakout sessions in Discord.